What's today's date?
It's the 11th.
All right. Can you guys see that okay? Yeah. Okay. They're a little finer tip to it, but as long as you guys can see it, it's all good. Okay, so when you're talking about bearings, okay, the true definition of a bearing is it's the positive angle from 0 to 360, and it's measured clockwise with respect to north. Okay, that's the very big general kind of definition, okay? And bearing basically is used to give direction in a lot of things, but basically a lot of times it's like aviation and nautical. Okay, so like when you're watching the movie and the submarine guy is talking and they always call out the burr 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 in the directional, and they go like south 15 west or whatever. That's they're giving it in bearing terms. Okay. All right. So we have two kind of bearings that we're going to talk about. Okay. There is quadrant bearing. Okay. And it is the acute angle between the vector and the north-south line. Okay, so this is considered my north-south line. Okay, so it's called the quadrant bearing because it determines, you use your quadrant in the direction. So over here, this one over here is, you give the angle measure, okay, and it's going east and south. Does that make sense? Because it's in that quadrant. And so you write it in respect to your y-axis and then your angle measure, and then in regards to your x-axis. Okay, does that kind of make sense? So if I had, let's say, a vector over here, and this is 30, I'm north in regards to my north-south axis. My angle measure is 30, and I'm west in regards to my x-y. Does that make sense? Okay. All right, that's quadrant bearing. So that way, if it's, west, it's on that side. If it's east, it's on that side, that kind of stuff. Then we have true bearing. Okay, and true bearing is the angle measured clockwise. Remember how we had a directional angle and it was in reference, we would go basically counterclockwise because we went in the direction of the unit circle? True bearing goes clockwise. All right, so it starts at the north, and so my true bearing here is going to be okay, this is how I gotta explain how the you basically do wait a minute, let me think here a minute. And so the true bearing is at 120 because I'm coming here to clockwise. If this is 60 and that makes it 30, so 90 plus 30 gives me the 120. Sorry, I was thinking about down below the next thing. Okay, and so true bearings are always written with 3 digits. Okay, so if you have a bearing of it, huh?
With 3 what?
3 digits?
I thought you said, you didn't say digits. You said digits. I said digits.
Oh.
I thought they were
Digits.
3 digits, sorry. This is one of those that there's like 4 different ways to like look at it, and it's kind of one of those, and once you wrap your head around it, you're like, oh, okay, that makes sense. So I'm trying to keep my brain very focused as far as which one, so I'm not thinking about what I'm saying. Okay, so let's do the quadrant bearing for the first one, okay? So we look at the actual angle measure, okay, because it's the acute angle from the vector and the north-south line. So that means I'm looking at that amount. Does that make sense? So that would give me 5 degrees, since the other one's 85. And I am in the northeast, so it would be north 5 degrees bearing east. Does that make sense? Okay, for this one, I have, well, this is the angle all the way, but we're comparing it in regards to the north-south. So I'm going to look at this part of the angle. And since this whole angle's 212, 212 minus 180 is going to give me 32. So this angle's 32. Are you with me? Which means this angle has to be 58. So I am south 58 degrees west. So your reference angle is always the angle that is attached to the XY axis. Does that make sense? All right, so the next one, since it's part of the angle attached to the north-south line, I have 24. I'm going to the north, and I'm going to the west. Are we good on those?
So the first one is always going to be north or south.
Correct.
Okay.
Yes, depending on if it's above the X or below the X. Okay, now for the true bearing, oops, just writing all over my hand. It's measured clockwise from the north of the vector, okay? So north of the vector, I'm just at 5 degrees, right? Because I'm going from north and till I get to the vector. So it's just 0, 0, 5 degrees. Okay? Good? Okay. For the second one, I start at the north, I go clockwise, and I go around. So I have 180 plus my 58, which then gives me, that was a big yawn. You're all right.
It's really tired.
I know. 238 degrees. Okay. What am I going to have on the next one? Start at the north line and go clockwise. So I'm going to be all the way around. So 360 minus 24 gives me 336. Does that make sense? Okay, so when you are putting vectors in component form, in fact, let me get a new color. Okay, so okay, the formula for the angle if it's not in quadrant 1 is going to be that you subtract your true bearing from 360, kind of like what we were doing up here. But then you add it to the 90 to get that directional angle thing because of the quadrant 1. If it's quadrant 1, then you don't have to do anything. You just use that regular. And that'll make a little more sense when we... Okay. All right, so let's look at our first one. We have an airplane flying at a bearing of 245 degrees. So that means I'm coming around, I hit 180, and then I keep coming around until I hit my 245. Okay? So that means the plane's flying, basically it would be then southwest, right? Okay, so when you do your, if you think about it, if we want to write a vector in component form, what two things do we have for our vector? What two things are vectors? There are two things. They measure what? Direction and magnitude, right? Or distance, okay? So your distance is going to be measured by how fast you're going. Does that make sense? So that means that I can write it in trig form. And so I would have that it's going 550 miles an hour. And this is where you use this formula, okay, to get it into the right directional angle, okay, because we can't have it in bearing form, we need it in directional angle. And so the cosine angle is going to be 90 plus the 360 minus 245. And then 550 sine the same thing. 90 plus 360 minus 245. Okay? So when you simplify it, you get 550 cosine of 205 and 550 sine of 205. With me? Sarah, where did I lose you?
No, I got it. That makes sense. I was just trying to.
Because basically, when we're having, if you're giving it into the bearing, we have to basically put it back into a directional angle, and that formula is gonna. It's like the 360 minus is what we did up here, but then we got to add that 90 degrees for that first quadrant. Does that make sense? So if you want to come up, simplify it so that it's 90 plus 360 gives you 450, and just remember that 450 minus the true bearing gives you the same thing. That's fine too, whichever way. I wanted to make sure you guys understood why we were doing what we were doing, instead of just, hey, subtract from 450. Okay? All right, so I can find my vector then, excuse me, of 550 cosine 205, which gives me a negative 498.47, and 5550 sine of 205, and that gives me a negative 232.44. And if you stop and think about it, I'm in this third quadrant, right? What are all my signs in the third quadrant? Negative, negative. So that makes sense that I'm going to get that negative, negative. Good? With me? What?
Nothing.
I think I'm just too tired.
Too tired. Okay. All right, so the next one. I got Mallory pushing a lawnmower with a force of 25 pounds. Uphill. At an angle of 40 degrees. Okay, so if we stop to think about what is this happening, okay? Well, here's the horizon. If she's pushing it up, since it's in the first quadrant, I don't have to worry about that whole 450 and all that good stuff. Okay? So, there's something stuck in my throat. Okay, so that means I can say my vector is going to be, what's my force? Well, 25, because that's going to be my speed, right? Cosine of 40, and then 25 sine of 40, which then just gives me 25 cosine of 40. So my vector is 19.15 and 25 sine of 40. And then 16.07. Good? And again, since it's first quadrant, the fact that both of them are positives, good sign, life is good. Next color. Orange. Okay. Got a cruise ship. He's sailing 20 watts in the direction of north 12 west. Okay, so what is that? Okay, here's north, here's west. So I know I'm going to be in that third quadrant, right? So where is my angle going to come from? What angle am I talking about? Well, I'm talking about, because it has to be in regards to the north-south line or my y-axis. So I'm talking about here, right? Does that make sense? Okay, so so my directional angle, is going to be from here or not directional, my true bearing angle is going to be 360 minus 12, right? Which is 348. Do you agree with that? Okay, so now I can apply, so I need this one. So I have 450 minus my true bearing of 348. Which gives me 102. Everybody with me on that? So now,
Where did you get 450 again?
because you're doing the 360 plus the 90, this is the formula. So I just combined it and made it simple into 450. But it just has to be the true bearing, and the true bearing is the one going clockwise. Does that make sense? All right, so what's my magnitude? What's my direction? What's my, or not my direction, what's my magnitude? What's my speed?
20 knots.
Mm-hmm. And so I have the cosine of 102, and then 20 sine of 102. What signs are you going to expect to get? Huh? A what?
Oh, sorry, 2.
No, you were right the first time. I think you just flip-flopped it around. What'd you say?
Negative.
Yeah, because I'm going up negative and up positive. So, yeah, you were.
I'm sorry.
No, I was going to say, I think you were right the first time. All right, so 20 cosine of 102. There's my negative. And 20 sine of 102 is 19.562. And there's your negative and your positive. Okay, does this make sense kind of in a little bit of a way? All right, because you've got about 10 minutes, and I'm going to give you 3 problems to do. So you should be able to do, let's see. We're going to do number 1 and number 2.
I think it's after school.
Actually, I'm going to give you 2 problems to practice. Surely you can get 2 problems done in 10 minutes. Surely. Don't call me Shirley. Was that airplane?